In this videotape, we're going to be reviewing the differentiation of algebraic functions. Let's start with a simple function, a polynomial. Y equals 7x cubed minus 4x squared plus 6x plus the square root of 2. This is a polynomial function. It's a sum of terms, each one of which is a constant times x to a power, where the power is a non-negative integer. Okay, third power, second power, first power, and you could still think of this as falling into that category because it's the square root of 2 times x to the 0 being 1. So it's a constant times x to a power, where the power is a non-negative integer. Okay, now we're interested in finding the derivative of this function. Let's take the derivative of both sides, the derivative of y with respect to x. Henceforth, we'll write this as dy dx. dy dx really means the derivative of y with respect to x. The derivative of y with respect to x will be the derivative of 7x cubed minus 4x squared plus 6x plus the square root of 2. Now we're interested in differentiating this polynomial. Now, luckily, we have 4 simple rules which will enable us to differentiate a polynomial like this. Let's look at the 4 rules now. Okay, the first of these rules says that if y equals f of x plus g of x, dy dx is f prime of x plus g prime of x. In other words, the derivative of a sum of 2 functions is equal to the sum of the derivatives of the individual functions. We assume, of course, that f and g are functions which are differentiable. By the way, this first rule can be extended to more than 2 functions. Actually, the derivative of a sum of any number of functions is equal to the sum of the derivatives of the individual functions. The second rule says that if y is a constant, its derivative is 0. The derivative of a constant is 0. The third rule says that if y is a constant times a function of x, the derivative will be the constant times the derivative of the function. In other words, the derivative of a constant times a function is the constant times the derivative of the function. Okay, and the last one tells us how to differentiate x to the nth power. If y is x to the nth power, its derivative is nx to the n minus 1. That is the power times x to the 1 less power. Okay, let's go back to our problem. We were faced with the derivative of the sum of 4 functions. According to our first rule, we can break this up into 4 smaller problems. Instead of worrying about the derivative of this whole mess, we can break it into the derivative of 7x cubed plus the derivative of minus 4x squared plus the derivative of 6x plus the derivative of the square root of 2. All of our derivatives, of course, are with respect to x. So instead of worrying about the derivative of this whole thing, we broke it up so that we have 4 smaller derivatives to handle. The derivative of 7x cubed, the derivative of minus 4x squared, the derivative of 6x, and the derivative of the square root of 2. The first rule allowed us to do that. The second rule told us how to handle the derivative of a constant. The derivative of a constant is 0, so we can eliminate that. That's just a plain constant. Here we have, however, constants times functions. Constant times a function of x. Constant times a function of x. The third rule told us, when faced with the derivative of a constant times a function, all we have to do is take the constant out in front. It's the constant times the derivative of the function. Instead of the derivative of 7x cubed, it's 7 times the derivative of x cubed. Instead of the derivative of minus 4x squared, it'll be minus 4 times the derivative of x squared. And instead of the derivative of 6x, it'll be 6 times the derivative of x, all derivatives with respect to x. Okay, so let's see what we did. Rule 1 let us break up the problem so that we had 4 smaller problems to work with. Rule 2 told us the derivative of a constant is 0, and we could ignore that. Rule 3 told us you can always pull a constant out in front of the derivative symbol. So instead of the derivative of 7x cubed, it was 7 times the derivative of x cubed. Now, if you've used rules 1, 2, and 3 in order on a polynomial, what we're left with now is the derivative in each case of x to a power, x to the third power, x to the second power, x, which is really x to the first power. Well, Rule 4 told us how to do the derivative of x to a power. according to Rule 4, the derivative of x to a power is the power times x to the 1 less power. The derivative of x cubed with respect to x is 3x to the 3 minus 1, 3x to the second power. Okay, so the derivative of x cubed with respect to x is 3x squared. Now, minus 4 times the derivative of x squared. The derivative of x to the second power, it's the power times x to the 1 less power, 2x to the first, or 2x. And the derivative of x to the first power is going to be the power 1 times x to the 1 less power, 1x to the 0. So what do we have here? We have 7 times 3x squared, 21x squared, minus 4 times 2x, minus 8x, plus 6, because x to the 0, of course, is 1. This is derivative of y with respect to x, or you could write it just dy dx. 21x squared minus 8x plus 6. Now actually, okay, with a little practice, you will be able to jump from the original problem to its derivative. Okay, let's see what we did. We looked at the polynomial and we broke it up into 4 smaller problems in this case. Okay, we decided we're going to differentiate term by term. The first rule allows us to differentiate term by term. The second rule allowed us to say the derivative of a constant was 0. The third rule allowed us to always pull the constant out in front of the derivative symbol. And the last rule allowed us to differentiate x to a power. So what's happening is you're coming down and you have pulled out the constant, and now the derivative of x to a power is the power times x to the 1 less power. So basically, in each term, it's the constant times the power x to the 1 less power. In other words, you could go from the original function to its derivative by following the simple rule that you're going to differentiate term by term. The derivative of a constant is 0, and for these terms, the derivative will be the constant times the power x to the 1 less power. The constant times the power x to the 1 less power. The constant, which is 6 times the power 1, x to the 1 less power. So it's possible to go straight to the answer here. The derivative of y with respect to x will be constant times the power x to the 1 less power, 21x squared minus 8x plus 6. Let's write that down. We need to know the derivative of a constant times x to a power. This seems to come up a lot when differentiating a polynomial. We know that we can pull the constant out in front of the derivative symbol, so it's the constant times the derivative of x to the power, and the derivative of x to a power is simply the power times x to the 1 less power. So quite simply, whenever you have to differentiate a constant times x to a power, it's simply going to be the constant times the power, c times n, x to the 1 less power. This will be very convenient when differentiating polynomials. The derivative of a constant times x to a power is the constant times the power, x to the 1 less power. Okay, let's go back over here and see. We started off with this polynomial, and we were able to figure out its derivative by saying, in each case, it was the constant times the power, 7 times 3, x to the 1 less power, 21x squared, minus 8x plus 6. Okay. Okay, for our second example, let's have y equals 5/2 x to the 4th power minus 7 over 3x to the 4th power. Now this is not a polynomial. If we rewrite this as 5/2 x to the 4th minus 7/3 x to the minus 4 power, because instead of having x to the 4th in the denominator, it can be moved into the numerator as x to the minus 4 power. Okay, it's not a polynomial, but it is a sum of terms, each one of which is a constant times x to a power. The reason it's not a polynomial is that we're allowing, to have a polynomial, you're only allowing non-negative integer powers. Okay, here we have a negative integer for a power. However, we can still basically differentiate it the same way, the way we would differentiate a polynomial. If we want the derivative of y with respect to x, this is still constant times x to a power. This is still a constant times x to a power. Remembering over here that the derivative of a constant times x to a power is the constant times the power x to the 1 less power, we will be able to get through this problem. Okay? We have a sum of terms. We know we can differentiate term by term. Okay? So it's going to be the derivative of 5/2 x to the 4th will be the constant 5/2 times the power 4 times x to the 1 less power. The constant times the power x to the 1 less power. 5/2 times 4, x to the 4 minus 1, or 3 power, third power. Now, going along, minus 7/3, the constant times the power, which is minus 4, x to the 1 less power. 4 minus 1 is 3. Minus 4 minus 1 is minus 5. Okay? So to differentiate this, we're going constant times the power x to the 1 less power, constant times the power x to the 1 less power. 1 less than 4 is 3. 1 less than minus 4 is minus 5. Be careful. Minus 4 minus 1 is minus 5, just like 4 minus 1 is 3. Okay, so dy dx is, okay, 2 goes into 4 twice, so we get 10 x cubed plus minus 7/3 times minus 4 is plus 28 thirds x to the minus 5, and this can be written either left in this form or written as 10x cubed plus 28 over 3 x to the 5th. In other words, the x to the minus 5 can be brought downstairs as x to the plus 5. So we can either leave it as 10x cubed plus 28 thirds x to the minus 5, or 10x cubed plus 28 thirds, and then x to the minus 5 can go downstairs as x to the 5th. Okay? So that's the answer to that problem. We were able to differentiate by using this rule over here. Derivative of a constant times x to a power is a constant times the power x to the 1 less power. That rule that we just had is really one of several that are going to be very important to us. It's a key rule for differentiating general algebraic functions, not just polynomials, as we've just seen in this example over here. This was not a polynomial, but it was very convenient to have that rule. Okay, I would like to call your attention now to several formulas that we're going to be using in our videotape. Okay, the first is our old friend, y equals cx to the nth power. C is the constant. Okay, the derivative of a constant times x to a power is the constant times the power x to the 1 less power. Okay, that's the one we just used. Okay, the second one, y equals f of x times g of x. If we want to differentiate a product, such as f of x times g of x, the rule is the derivative of a product is the first function, f of x, times the derivative of the second, g prime of x, plus the second function, g of x, times the derivative of the first, f prime of x. Of course, we're assuming that both f and g are differentiable functions. So the derivative of a product is the first times the derivative of the second, plus the second times the derivative of the first. The third line, we have the familiar quotient rule. If we have a quotient, f of x over g of x, the derivative of a quotient is the denominator times the derivative of the numerator minus the numerator times the derivative of the denominator. And then finally, we have our power rule. If y is a function to a power, f of x to the nth power, the derivative is going to be the power times the function to the 1 less power times the derivative of the inside. Don't forget that extra f prime of x. That comes from the chain rule, and it's very important. The derivative of a function to a power is the power times the function to the 1 less power times the derivative of the inside. So we have these 4 rules. Let's see. We'll call the first one our polynomial type rule, if we want to refer to it. The second one will be our product rule. The third, our quotient rule. And the last, our power rule. The polynomial rule, the product rule, the quotient rule, and the power rule. Okay? It's not enough to just know these rules. You have to know when you can use them and when you can't use them. Okay? Let's try some examples. For our third example, let's look at y equals 5x cubed minus 7x all raised to the 4th power. Okay, and what you have to do basically is to mentally go through the 4 formulas that we've just had and decide which one of them best describes the form of this function. We have 5x cubed minus 7x to the 4th power. Okay, well, this is not terribly difficult. Of the 4 formulas that we had, the one that this most looks like is the last one, the one that said y equals f of x to the nth power. This is an example of the power rule. Okay, to get the derivative of this function to a power, according to the 4th rule, the derivative of a function to a power is going to be the power times the function to the 1 less power times the derivative of the inside. Okay? The derivative of a function to a power is the power times the function to the 1 less power times the derivative of the inside. So we need the derivative of 5x cubed minus 7x with respect to x. The inside, of course, is a polynomial. We'll differentiate that the way we did by the method we learned in the first example. The derivative of 5x cubed is constant times the power, that's 15, x to the 1 less power, 15x squared. And here, this is really to the 1st power, so the constant times the power minus 7, x to the 0. So the derivative of a function to a power is the power times the function to the 1 less power times the derivative of the inside. The derivative of the inside, there we had to use our polynomial rule, constant times the power, x to the 1 less power. So 15x squared minus 7. Okay, a common mistake that people make is they put the power times the derivative to the 1 less power, but that's not what formula the 4th rule said. This is not what the power rule said. It says power function to the 1 less power times the derivative of the function. Okay, power function 1 less power times derivative of the function. Okay, let's try another example. Y equals x squared plus 3x to the 5th power times 7 minus 4x to the 8th power. Okay, look at that function. Now your job is to remember the 4 rules that we had earlier and decide which one of those 4 rules best describes this function. Let's look at those 4 rules again. Okay, we have 4 choices. It's going to get harder later on. We're going to have more differentiation formulas, but basically now we have 4 basic rules. The polynomial rule, the product rule, the quotient rule, and the power rule. And you're going to have to decide which one of these 4 rules best describes this problem. Let's look at the problem. Okay, let's go back to the problem and see what the problem looks like. Okay. Is it a polynomial? Well, if you expanded everything, you could get a polynomial out of it, but certainly the way it's written now, it doesn't exactly fall into the polynomial category. Okay? What it most looks like is a product. Okay, I know you see the powers, but what you have to do is to ignore the powers temporarily and say that this is basically a product. It's something times something. Okay, it's true the somethings themselves are powers, but we'll get to that later on. Right now, this is a product. It's something times something. That's what best describes. That's the one word, polynomial, product, quotient, or power. The one that best describes this is a product, excuse me. Okay, the derivative of a product is going to be the first function times the derivative of the second plus the second function times the derivative of the first. The first function times the derivative of the second plus the second function times the derivative of the first. Okay, leave yourself space to fill in the derivative of the second and the derivative of the first. Okay, a common mistake, people get all excited, they take the product of the derivatives. That's not true. Okay, the derivative of a product is the first function times the derivative of the second plus the second function times the derivative of the first. Then when you want to differentiate the second function, you say, okay, which one of the four formulas does this look most like? Okay, well, this looks most like a power. So when it comes to differentiating the second function, you say, okay, this is a power. And I'll differentiate it by the method I used in the last example. The derivative of a power is, a function to a power is the power times the function to the 1 less power times the derivative of the inside. The derivative of 7, of course, is 0. Derivative of a constant is 0. Derivative of minus 4x is minus 4. So when it comes to the derivative of the second part here, it's a function to a power. It's the power function to the 1 less power times the derivative of the inside. Now we have the second times the derivative of the first. Okay, the reason I recommend writing derivative of the first is that after you finish this, if you haven't mapped it out like this, you may forget that there is even a second part to the product rule. When you're working out a problem, you tend to get confused. So it's better to go through it and say, okay, it's a product. First times the derivative of the second plus second times the derivative of the first, and then go back and fill in what you need. Now, the derivative of the first is also a function to a power. So once again, we will use the power rule. The derivative of a function to a power is the power times the function to the 1 less power times the derivative of the inside. The derivative of x squared plus 3x with respect to x, this is a polynomial. The derivative will be, okay, the constant times the power, 2x to the 1 less power, so 2x, plus the derivative of 3x with respect to x, which is 3. So power, function, 1 less power, derivative of the inside. And we have been able to write out the derivative of this complicated product simply by following it one step at a time. First to say it's the first times the derivative of the second, then plus the second times the derivative of the first, and then to fill in the power rule where it was needed. For my next example, let's try this. Y equals 3x over x squared plus 4. Okay, well, this is a fairly straightforward problem. It is clearly a quotient. Okay, we don't even have to go back to the formulas to see that this is really like f of x over g of x. It's a quotient. So the derivative of a quotient will be the denominator times the derivative of the numerator minus the numerator times the derivative of the denominator all over the denominator squared. Okay, the bottom times the derivative of the top minus the top times the derivative of the bottom all over the bottom squared. Bottom times the derivative of the top minus the top times the derivative of the bottom all over the bottom squared. Now, the derivative of the top is needed here. Well, that's just a monomial. It's a constant times x to a power, so it's 3 times 1, x to the 0, or just 3. The derivative of the top is simply 3. The derivative of the bottom, of course, is 2x plus 0, or just 2x. So we get, simplifying, distributing the 3, 3x squared plus 12 minus 6x squared all over x squared plus 4 squared, or 12 minus 3x squared. 3x squared minus 6x squared, so minus 3x squared over x squared plus 4 squared. Okay, for our next example, let's try the following. Y equals 5x over 4x squared minus 3, all raised to the 10th power. Okay, once again, in order to get started, we're going to have to decide which of the 4 rules should be used. And as I said, later on, we're going to have more rules. So let's get these 4 straightened out. Okay, we have 5x over 4x squared minus 3 to the 10th power. Let's look at those 4 formulas again. Okay, we have the polynomial choice, the product choice, the quotient choice, and function to a power, the power rule. Okay, now which one best describes the problem that we were dealing with? Let's go back and look at the blackboard. Okay, now I know you see the quotient here. Okay, everybody sees the quotient, but that doesn't really best describe what's going on here. This is essentially a function to a power. You'll get your chance to use the quotient rule, okay, but you have to wait your turn. This is really a function to a power. So the derivative of a function to a power is the power 10 times the function 5x over 4x squared minus 3 to the 1 less power times the derivative of the inside. Okay? It's going to be the power times the function to the 1 less power times the derivative of the inside. You've used your power rule. Now comes your chance to say, what is the derivative of the inside? The inside is a quotient. Okay? Now's your chance to use the quotient rule. To get the derivative of a quotient, it will be the bottom times the derivative of the top minus the top times the derivative of the bottom all over the bottom squared. Bottom times the derivative of the top minus the top times the derivative of the bottom all over the bottom squared. Okay? Bottom times the derivative of the top. The derivative of 5x with respect to x is 5. Minus the top times the derivative of the bottom. The derivative of 4x squared minus 3 with respect to x, using our polynomial rule, is 8x. Okay, so we have the derivative of a function to a power. The power times the function to the 1 less power times the derivative of the inside. The inside, however, was a quotient. So it's the bottom times the derivative of the top minus the top times the derivative of the bottom all over the bottom squared. Let's try another example. Y equals x cubed times the square root of 1 plus x squared. We have to ask ourselves, what is this essentially? Okay? Well, primarily this is a product. It's really x cubed, x to the third power, times 1 plus x squared to the 1/2 power. The square root of something is that something to the 1/2 power. So this is really a product. To get the derivative, we will use the product rule. It will be the first times the derivative of the second plus the second root of 1 plus x squared times the derivative of the first. Okay? We're going to use the product rule. It's going to be the first function times the derivative of the second plus the second function times the derivative of the first. Okay, well, the derivative of the first is easy. The derivative of x cubed is just power x to the 1 less power, or 3x squared. Now, the derivative of the second is a function to a power. That's our power rule. The derivative of a function to a power is the power 1/2 times the function 1 plus x squared to the 1 less power. That's 1/2 minus 1. 1/2 minus 1 is 1/2 minus 2/2, so minus 1/2, times the derivative of the inside. Power, function, 1 less power, times the derivative of the inside. The derivative of 1 is 0. The derivative of x squared with respect to x is 2x. First times the derivative of the second, plus the second times the derivative of the first. The derivative of the first was easy enough. That was just x to the third power. The derivative was 3x squared. The derivative of the second required the use of the power rule. The derivative of function to a power is the power times the function to the 1 less power times the derivative of the inside. Okay? Just a little bit of simplification here to remind you how you would go about doing it. The 2's can cancel. You can divide numerator and denominator by 2. We have an x cubed here and an x here. That's x to the 4th. This 1 plus x squared to the minus 1/2 power can go downstairs as 1 plus x squared to the 1/2 power. But the 1/2 power is the square root. So we can write it x to the 4th over the square root of 1 plus x squared plus now the 3x squared times the square root of 1 plus x squared. So x to the fourth over the square root of 1 plus x squared plus 3x squared times the square root of 1 plus x squared. Okay, let me show you again how that works. The 2's canceled. This x mixed with the x cubed to get x to the fourth. This quantity to the minus 1/2 power went downstairs to the 1/2 power, but the 1/2 power became the square root. So it's x to the fourth over the square root of 1 plus x squared plus, and here I just switched the order a little. You could have left it this way or written 3x squared times the square root of 1 plus x squared. For our last problem today, let's try the following. Y equals 5x over x squared plus 3 times 6 over x minus 4x squared to the 5th power. Okay, 5x over x squared plus 3 times 6 over x minus 4x squared, all raised to the 5th power. Okay, look at that and try to decide which of the basic types it comes under. Is it a polynomial, a product, a quotient, or a power? Now, I wouldn't blame you if you were confused, because it looks a little like many of them. I see a quotient here. I see a power here. Okay? This thing here is a polynomial, but what really describes this the best? This is really a product. It's really something times something. What you must be able to do is develop this ability to look at a problem and to see what one word describes it. Polynomial, product, quotient, or power. And this is primarily a product. Okay, you'll get your chance to use the other rules, but right now, think of this as a product. Okay? You can also, by the way, rewrite this as 5x over x squared plus 3 times, instead of 6 over x, you could write that 6x to the minus 1 minus 4x squared, all to the 5th. This has the advantage of when you want to differentiate it, you can do it the way by the method we use in the second problem. And it's not a polynomial, but it can be done by the polynomial type rule. Okay, so 6 over x you'd have to do as a quotient. 6x to the minus 1 you do by the rule cx to the n. So that's convenient. Let's write down the derivative. We decided this was essentially a product. So it's going to be the first 5x over x squared plus 3 times the derivative of the second. That looks a little complicated. Let's leave some room for that. Plus the second, 6x to the minus 1 minus 4x squared to the 5th times the derivative of the first. First times the derivative of the second plus the second times the derivative of the first. Okay, so we essentially feel this is a product. It's the first times the derivative will be the first times the derivative of the second plus the second times the derivative of the first. Now we need to differentiate the second. That's your chance to classify the second part of this. Okay? Well, which is it? Is it polynomial, product, power, quotient? This is a power. It's a function to a power. So to differentiate the second, we will use the power rule. It will be the power times the function to the 1 less power times the derivative of the inside. Okay, power, function, 1 less power. Now we need the derivative of the inside. But this is cx to the n, so is this. So we can use the cx to the n rule, the polynomial type rule. The derivative of cx to the n is c times n, x to the n minus 1. Derivative of a constant times x to a power is the constant times the power x to the 1 less power. So constant times the power, that's minus 6, x to the 1 less power, minus 1, that's minus 2. Here, the constant times the power, that's minus 8, x to the 1 less power, that's x to the first power. So minus 6x to the minus 2 minus 8x is the derivative of the inside. So let's see, we have the first times the derivative of the second. The second was a function to a power. The derivative was power, function, 1 less power, times the derivative of the inside. Now we need the second times the derivative of the first. Let's look at the first. The first is essentially a quotient. Okay? This is a quotient. The derivative of a quotient, we will use the quotient rule. The derivative of the first will be the bottom times the derivative of the top minus the top times the derivative of the bottom all over the bottom squared. The derivative of the first, using the quotient rule, the bottom times the derivative of the top. The derivative of 5x with respect to x is just 5, minus the top times the derivative of the bottom. This polynomial, the derivative is just 2x with respect to x. Bottom times the derivative of the top minus the top times the derivative of the bottom all over the bottom squared. Okay, that brings us to the end of this problem. Let's look at the formulas one more time before we finish. Okay, you have 4 basic rules for differentiating algebraic functions: a polynomial type rule, a product rule, a quotient rule, and a power rule. Okay? It's not enough to just memorize these formulas. As you've seen, as we've gone through these problems, you need to know which formula to use in each example. And sometimes it can be confusing. Sometimes you can't quite make up your mind. You have to ask yourself which one word describes it. Is it polynomial, product, quotient, or power? Okay, later on you'll use the other rules, but your starting one is very important. And that brings us to the end of this tape.